Oh, I got it. Okay. So that's okay, so yeah, like I said, next Tuesday, October 10th, there'll be an open note quiz. This covers 3-1 and chapter 3-2. So you'll be reviewing Friday and Monday for that. So this was finding x-intercepts. It was solving by square rooting. It was factoring. And then yesterday's work was this I. And today's work, today we're going to multiply imaginary numbers. It's a typo here, sorry about that. And actually, I wish the word by wasn't in there as well. Multiply imaginary numbers. So the one thing you should know going into today's lesson, this is a fact, I squared equals -1. So whenever we multiply and we get I squared, we take it out and we put a -1 in. Okay, so if you want to write that down and highlight it, we're multiplying like you always have, but if you get the I squared, you put a -1 in and keep going. Okay? You want me to explain it? I can. So, like, you guys know the square root of 25 is 5. And the square root of 5 squared is so the square root of -1 is I. So really this is I. But if I square it, it goes back to just being -1. It's like a full circle. It takes it back to its original -1. Alright. So anyway, number 1, we ended class yesterday with just combining like terms. So we got your 8 that combines with your 5, that makes 13. The -I can add to 4I to make 3I. Any questions on combining like terms? Alright, let's head to page 202 and we'll talk a little bit about electricity. We don't talk enough about electricity. We all should understand electricity much more than we do. It's actually kind of tragic that our K through 12 schooling doesn't teach more about electricity. Did you guys know that we have a lot of electricity in our bodies? Any of you certified in CPR? What's that thing called where they put the 2 paddles on your body and they clear? A defibrillator. What does it? Anybody know what a defibrillator does? It puts an electrical pulse in your body if your heart isn't pumping, and that electricity gets your heart pumping more. Our heart is actually electric pulses, so we have electricity in us. Did you know our dirt, our whole earth, is an electricity conductor? That we can put little we can put a multimeter into the ground and we can see the voltage of our dirt. Sand conducts less electricity than clay.
Is that what they call it? Negative rails? When they say positive negative rails.
Anyway, we should all understand electricity more than we do. So let's take a look at this. This is really vocabulary. Okay, be quiet. So this is kind of introducing you to the vocabulary 11th grade, maybe you're in 11th grade, 12th grade, you understand a little bit, but then you choose to take some electrical engineering classes in college. You know, in 6 years, you could understand electricity so much more than you do right now if you just don't shy away from it, if you're interested in it. There's electricity everywhere here, and none of us have any idea how it's working. That's weird. That's weird. We should know more about this. Okay? So let's start with just some vocabulary. Electrical circuit. You guys have broken something, an old thing, maybe took a hammer to it and found the circuit board? Anybody? Yeah.
Accidentally, but yeah.
Okay. Electrical circuit components such as resistors, inductors, and capacitors all oppose the flow of current. What does it mean by the flow of current? Well, let's say we have something here that has like an electrical current. If we connect a wire to it and then put a light bulb on this side, there is a current that will light up the light bulb. Now, if we don't put a switch in there somewhere, the light bulb will always stay lit. So a lot of electrical engineers are just figuring out what kind of switch they want in there to hold off the current and then to let the current go. So resistors, inductors, and capacitors will oppose the flow of current. This opposition is called resistance for resistors and reactance for inductors and capacitors. Each of these quantities is measured in ohms. All right, you already know inches, seconds, miles, you know, degrees, you know, pounds, you know, kilograms. You should also know ohms. That's how we measure these electrical components. The symbol for ohms is the omega Greek letter. So this table is actually informing us how to read this circuit here. The table shows the relationship between a component's resistance and reactance and its contribution to impedance. A series circuit is also shown with the resistance or reactance of each component labeled. The impedance for a series circuit is the sum. I had no idea what I was reading until I read sum. And I thought, oh, that just means addition, right? So finally a math term. It's the sum of the impedances for the individual components. So really we just have to add all these things up. You guys know sum means addition. So we have to match the symbols here to this table. So a squiggly spring is an inductor. An inductor